I think. Oh my God. So, hi everyone. Oh my God, I've got at least 3 people in the chat. How's it going? Firstly, I am sorry I was late. I have just finished my run. I've just had a shower and I've had a like half-second bite to eat. And this is the first time I've done this as well. So I don't even know. Let me just check. Yeah, I'm actually on the internet. I can see my shiny face. Oh, I forgot to do my green screen. One sec. See, I'm such a pro. Right. Oh, right, calm down. Hello, Ralph. Hi, Tobo. Hi, Paul. How's it going? Woo. Right. Now let me just get myself. Literally just rushed into the office, and luckily I did all this morning when I had a spare moment. So, oh, sorry, I'm still a bit sweaty from my run. Okay, thumbnail. I've got this one which shows fusion and what I'm doing, and let's get rid of that. And oh, I'm sorry. Oh my God, what a noob. Okay, yeah, I got it. It's when I was on that other screen. I didn't have my mic technology. Okay, I'm back on. I know what I did there. Sorry about that. So basically, I've been a terrible YouTuber. I don't know where it cut out before, so I'll just start again. Hi, everyone. I've been just kind of really busy and not really motivated. I've had a few issues with YouTube and stuff, but it's like kind of in the long distant past. And I'd like to get back into it, and I've got loads of stuff shot, but it's the editing that's really ground me down. I've actually got some stuff from like 2 years ago that I've still not edited together. Oh, I can look at your camera there. And essentially, I'm just going to pull my finger out and actually do it. But this is my first live stream, and I thought, you know, what's better than having to edit? Let's just do it live, and let's see what happens. Okay, so hi everybody again. Tobo, Paul, Ralph, how's it going? Kevin, hello mate. So let me just have a quick drink of water. God, I really should have ended my run earlier. I really ran my butt off to try and get back in time. I should have shortened it, but it was hard. Okay. So my plan today is to use Fusion 360, which is software I love, and I'm going to essentially just try and make a pattern for printing later. And then part 2 of this. Hi Albert, how's it going? Hi from Britain. I hope you're okay. And print it, and then in part 2 of this we'll be casting it. Now the plan is, I don't know if you can see this, but I've purchased a sieve. But it's actually a stainless steel. So the problem is with greensand casting, it's always the sand prep, and all I've got is a kind of a gardener's sieve, and the wire mesh on the gardener's sieve is actually quite sharp. It's a bit like cheese wire. Hi Mark, oh my God. Hi Albert, Tobo, Kevin, all you guys. I can't believe you guys have shown up. This is so awesome. So the wire itself is super thin, and after sort of sorting out my sand, my fingers are like rubbed raw. And also, it's not stainless steel, the mesh. It's I think it's just sort of rubbishy steel, so it rusts. So I went online and I bought this stainless steel mesh. Now it actually comes in 8 foot by 4 foot sheets. This is a sample sheet. I actually bought 2. This one is, I think this is a 6mm mesh, and I can see now when it's in front of me, it's too big. But the sand mesh, the size of sand mesh I use is, I think, 4mm. For my green sand, that seems to be the best size, and that's what this is. So my plan is to cast a shape actually through this or with it, so it's kind of cast into it, if you see what I mean. Let me just see if I can. So yeah, the plan is to kind of make a sieve shape in the drag, and the bottom of the sieve in the cope, and then cut this out in the particular shape required and put that between the two. Now this does have thickness, so there is a little bit of a difficulty. Obviously the cope and the drag might not sit together nicely. I mean, it is a sieve, it will compress slightly in the sand, but there are some problems. I mean, whether the aluminium will kind of flow up to the edge, and I want it to flow across the kind of sharp edges here, but I don't want it to kind of keep flowing in the gap and then basically fill the whole thing with like and basically become an aluminium sheet with steel reinforcing. That would be really bad. Equally, once the aluminium is flowing in, it might actually spill out of the gap because the cope and the drag are actually separated by the mesh. I don't know whether to make a pattern for the mesh, and when I'm doing the cope and the drag, actually account for that thickness. I think that's probably the way to do it. But anyway, let's actually get going on Fusion 360. Now, I know you guys, most of you guys know all about designing patterns and things. I'm just going to kind of talk as if you guys aren't my main audience, and I'm just kind of going to start from basics. So obviously when you're sand casting, you want to be able to have a pattern that you push the sand aside and then you remove the pattern, and it leaves a void in the sand, which you will then fill with metal to pour it in, and it fills the void, and then basically you've got a solid object made of metal, the same shape as the pattern, and that's basically what casting is. So let me just shrink myself here. Ooh. Oh, look at my terrible green screen. What's going on there? Oh, let me just sort that out. I'm doing some office upgrades. Oh, that's even worse. I'm doing some office upgrades, and actually a proper green curtain is like a curtain rail that I can hang my, because there's a big bunch of shelves there, but the shelves end there, and there's another corner. Anyway, irrelevant. So let me just shrink myself down here. So I've got, the first thing I'm going to do is I'm going to do the shape of the flask. Now let me see here. I've written down all my flask sizes because I've done this mistake before. Make a pattern that you think is an awesome idea, and then actually you come to put it in your flask and it won't fit. There needs to be a bit of a gap around it. So this is a completely brand new design in Fusion. I'm going to create a sketch. Now I'm going to have it centered. Can you guys see that? So let me just do the actual outline of the inside of my, so this is my largest 317 by 435. So let's do 317. Oh my goodness. Oh. So I clean my keyboard and some of my keys aren't working. Brilliant. 435. Okay. Oh, I've also got to show you guys this thing. This, I got this about 2 months ago. So it's a mouse, but digitizer. Hello, mate. So it's a mouse, but it's specifically meant for kind of 3D applications. So I've actually got a mouse as well. This is I use one of these rollerball mouse things, but using this, I can kind of spin and sort of look at stuff at the same time as pointing with the other mouse. See, I've ruined it now. Right, let's get organized. So this is the shape of the inside of my flask. I'm just literally going to arbitrarily just make it, I don't know. That isn't the shape of the flask, but so let's just make a flask. Now the flask itself is 132 in depth. New body. And I'm going to make the cope and the... silly boy. Okay, so I'm going to make a new body. I'm going to make, this one's 99. So this was the, I need to make that minus 99. So this was the flask I used to do my kettlebells. And it's huge. Oh no. What an idiot. Okay. New body. Oh my goodness, I don't know what's happened. My minus 99, new body. Okay, phew, right. What a plonker. So that's essentially the size of the flask, and this blue rectangle in the middle, that is where the sand meets, and that's the parting line. So that is where the mesh essentially is going to go on this flask, on this sieve. So basically I'm going to leave it like that, and now I'm going to start a new sketch, and now we're going to do the actual sieve. Now I reckon I need a sieve that is 26 centimeters by 26 centimeters. Something's going on with my keyboard. Really bad. I shouldn't have bothered cleaning it, should I? I was so embarrassed by the state of it. Okay, so that's 260 by 260. Because we're casting it, yeah, thanks Taz, I will do that. And because we're going to cast it, I might as well make it nice and curved on the edges. Now I discovered, I'm not an expert on Fusion 360 by the way, by any means, but I discovered this fillet option here, and you can just literally pick two corners, and I think a radius of 30 would be nice. So this is actually a very simple design, so it actually shouldn't take too long. Radius of 30, and again last one. Okay, so that's the outside dimension of the sieve, and once I add this offset, I think you'll see where I'm getting to. Now the base of the sieve at the parting line I think needs to be about 10 millimeters wide, which is quite wide, but I need it to be able to kind of flow onto some mesh. So I need at least, I think, 5 millimeters of mesh to kind of grab it. Another problem that could occur is the mesh might warp once the molten aluminium is poured in. Basically, this is literally just a bit of fun. I don't know what will happen when it happens. So I think 10 millimeters. And essentially, that is the sieve, but sliced through the parting line. And all we're going to do is extrude the top. But being a sand casting type operation, we're going to do some draft on it. Now, because it's quite tall, I'm actually going to have a very slight draft of -3 degrees. And I want the whole thing, so can you see there, it's got some draft to it. That's to enable it to be pulled out of the sand. And I've written some measurements here. One sec. Okay, so I think I want to make it 60 high. So essentially that is the top part of the sieve, and this sort of edge here, in fact I might put the mesh in. Let's put the mesh in. What we need to do is for the mesh, can I do another offset? Okay. Don't be like that. I know. Finish sketch. I'll do another sketch. Create sketch on the same plane. And what I will do is I will, let me get rid of that, I will project. Sometimes Fusion does do some silly things. I will project the sketch through from the other sketch onto this sketch. Okay, so hopefully, yes, I'll be able to offset. Basically, I want it to be the same shape as this, the mesh. This is just a simulation for the mesh, obviously. Now, I want the mesh to go inside the aluminium. By how much? I don't know. I reckon 4 millimeters. I guess that's a good size. Maybe let's go with 5. I can always sort of, this is just kind of guesswork. SW Dweeb, hello mate, how's it going? So the mesh, incidentally, I think I spoke to Perry, SW Dweeb, about my sieve idea, I don't know, was it like a year ago? And you'd had a similar idea yourself. So right, what's going on here? Okay, so I can select that and that. Now the mesh, I'm just going to make, I think the mesh is 3 millimeters. I'm just going to label up my. Now let's add. So now we've got the cope, the drag, the mesh, the top of the sieve. Let's actually, that one there is the drag. This one is the cope. I'm going to call this the. What am I going to call this? Top of sieve. By the way, can I just formally say that the word sieve is a terrible word. I cannot spell it. Let's get rid of the drag and the cope. So right, that's the sieve. And as you can see, I might actually colour the. I'm going to colour the mesh. Favourites. Now I've got some favourites down here. Ooh, have I actually got mesh? Oh, stainless steel mesh. That'll do. Hexagonal mesh, stainless steel mesh wire. That'll do. Okay, so perfect. Yes, Tobo, I think that is a good idea, because it does have thickness that is probably, because it's got such a large area, I don't think the cope and the drag are going to sit nicely together. It's not like you're putting a little tiny inch by inch bit of mesh on there and it will just squish through, the sand won't squish through. So I think that will be a good idea. But whether it needs to be in the drag side or the cope side, I don't know. Perry says, I keep thinking I need to make one of these as well. I was assuming I'd cast the mesh into the sides. Yes, that's exactly what I'm going to try and do. But when I'm making the mold, I'm pretty sure the mesh, because it's quite big, will separate the cope and the drag, and I don't want aluminium pouring out the sides. So yeah, I think that's a good idea, Tobo. I think that is the plan. Essentially, I'm going to 3D print the mesh thickness, but by how much I don't know. Also, another problem is, I did mention it at the start, once the aluminium goes into here, there's not a lot to stop it kind of flowing into the mesh itself, which is good because that's where it's going to be held, but there's not a lot to stop it. I'm hoping it will stop at least once it hits one of these horizontal wires. I don't want it to keep flowing sort of in and out, because the mesh is obviously like a wave. It's not actually a wall to stop the aluminium. So I don't know. I'm hoping that it'll cool when it hits the mesh itself, but not so much that it doesn't actually kind of impinge a little and hold it in. So right, we're nearly there. All we've got to do now is do the bottom, and all I'm going to do is select the bottom there and extrude it out. Now, I don't know, I'm saying maybe 10. I'm literally making this up. 10 millimeters, and I can afford a larger taper on this side. 7. That seems a bit much. Let's do a 6 because it's only small. Because I actually want a bit of the width here, because I might put one of my... Actually, no, let's go with 7. Try and reduce some of the aluminium. So I don't want to join. I want to make a new body. Okay. So this is bottom of sieve. Is it EI or IE? It's IE. All right. So that is essentially the whole thing. Now I just need to think about how I'm going to print it. Now the trouble is, this is too big for my printer. So what I like to do normally, especially if I've been fairly careful from the start like I have now, I've designed the whole thing with this origin dead center. So it's actually very easy in Fusion to just grab a whole what they call body. So this top of sieve is called a body, and I can just slice it. So I'm going to split the body, and I'm going to use the origin. I'm going to split it down the whatever that is. I think that's probably the, I don't know, X, Y, or Z. It's one of those two. So I can split that. So that is now split into 2. So I've got this side and this side. Now I'm actually going to split it again, because essentially what I'm going to do is print it in quarters, because then hopefully I'll be able to kind of stack them like chevrons on my 3D printer. I'll certainly be able to do 2. But that does give another problem. So I'll split this one, and I will use this axis. As you can see, it's going to slice it through there where the pink is. Great, and do the same for this one. Splitting tool there, got a bit confused. Right. So that is the top of the sieve, split into 4. I need to do the same for the bottom of the sieve. So I'll select that, split this using the same 3 axes, or 2 axes. That's that one done. Now I just select this. Incidentally, Perry, did you see my fancy mouse? I don't think you were here at the start when I mentioned it. It's so cool. I think you'll be very jealous. And I'll just split this one as well. Okay. So that is the top into 4 parts and the bottom into 4 parts. And because it's square, essentially, we can actually just print one corner and do it 4 times, if you see what I mean. This could be modular in a way. I could make a kind of an extension piece in the middle if I wanted a rectangular one. So the trouble is, because this is going to be printed in 4 corners, not all in one go, I don't have a big enough printer, I'm going to need some sort of registration thing going on to keep everything together. And it's also nice when you're pulling out the pattern, if they're all really flimsily held together with super glue, if you pull out the pattern, there's a good chance you might pull the pattern apart and just ruin everything. So I'm actually going to, let's see, which ones are we going to use? When I go like that, okay, perfect. So I'm going to use top of sieve. I'm going to keep that one. I'm going to hide these. And I want this one. Perfect. I'll hide all of these. So that's really what our sieve has come down to. In fact, I'm going to colour this. Appearance. I'm going to make the top green for no real reason. And the bottom I shall make red. I hope you can't hear my... Oh, you didn't hear that? Did I see what? You didn't see my fancy... I hope you didn't hear my stomach rumbling. It's because I've just scoffed like a sandwich literally in about 30 seconds. Check this out, Perry. This is an amazing 3D mouse. I can pull and push, rotate, spin. It's super fancy. And it's also lovely and smooth. Before I had this mouse, I would have to use this thing and kind of be jerking around, and it's just no good. So when I print this, I'm going to print 4 of these, and I'm also going to print 4 of these. Now the flat bottoms where they meet, that'll be the bottom of the print surface. That'll be nice and flat, so that when they're in the pattern they will meet nicely. And I need a few things. So I need to be able to registrate. I need to have registration pins, and the ones I use these on all my patterns now. They are, let me see if I can get this, they are super, let me just zoom in. See these little things here? Super small, but they are extremely good tolerances and they're really cheap. I get them off Amazon. I've actually got I've got a little page here to show you. Basically, that from Amazon, they're the things that hold shelves up. 3mm by 25mm dowel pin, stainless steel, and you can get them in any sizes. They're the same. They're all 3mm, but you can get them in 10, 12, 16s. 25s are kind of useful because you can kind of put a good length in each side of the pattern. And incidentally, this was the place I bought the mesh. I bought this number 4 mesh and this number 5 mesh, but I did it in a kind of a sample size. Right, let's get rid of that. Perry, you missed the start where I was talking for ages and I was muted. What a numpty. Okay, so these parts need to hold together well in the pattern so that when you're bashing the sand, they don't move around and also they don't break apart. So I'm going to put some of these pins, I'm going to put holes for the pins in these patterns. So let's see, we've got top of the sieve. I'm actually going to do the sides first. Now I know from experience, I printed a little a little block here on my 3D printer, and I know that for a nice loose fit, it's like 3.2 millimeters, 3.25. That's like that. Actually, so this one's 3.3, and that's a nice loose fit. But if I want a nice tight fit, i.e. holding the bits together that I don't want to come apart, I've written it down here, 3.15. So if I make a hole of diameter 3.15, this is a really nice tight press fit. So what I'm going to do is I'm going to put a hole here, sketch, circle, I'm going to zoom in. So I think, now what's that, 5 millimeters? So I'm literally going to put a circle there, 3.15. Now I'm only going to make one of these pins. So this is going to be my pin here. I've made a circle, and like everything on these 3D softwares, you essentially just extrude. Now I'm actually going to do it symmetrically, and I'm going to do the whole length, and I'm going to make the whole thing. Now the pin is actually 25, but I want the hole to be 27, so there's a little bit of play in case a bit of plastic gets stuck in there. It's nothing so annoying as putting your pins together and then the actual parts won't squeeze together. So a little bit of leeway is good. So I'm going to make a new body, and this is like the negative of the hole I want. So this is now, there's the pin there. It's 27 long instead of 25, but it's the right width for a tight fit. Okay, so I'm going to call this pin 1. Now, I'm actually going to copy this part. Super easy. Right click, copy. Oh, he says. So right click, move. And when I'm moving something, I can also copy it if I click this. So I click copy. Shove it up. Now I've got to be a bit careful. I want another pin up here as well. So don't forget, these pins are to join the 4 quarters together nice and tightly. But if I put them too high up, it's going to kind of impinge on the side. Now when you're 3D printing, it's a bit like toothpaste coming out of a toothpaste tube. There does need to be a certain amount of thickness around a part, and just from experience, this is too high. I need it to be, I would say around here is probably fine. So why don't I just make this 27? Okay. So I've moved that pin up here 27 from where it was down there. So now I've got 2 pins. Perfect. Actually, I should have been a bit more cunning. What I like to do also is just put a tiny chamfer on the hole. It just makes it a bit more accurate. 0.3. So I'm going to have to do it for all 4 of them now, which is kind of annoying. The 4 ends. Okay, so chamfer 0.3. So as you can see, when this gets printed, there won't be such a, I mean, it's only a small thing, it's 3 millimeters, but I like to sort of put a little bit of chamfer on things when I can. So right, there are the pins. Now I'm actually going to move, I'm going to copy this one and I'm going to put it down here too. I'm going to put one in here, and it looks to me like 10 millimeters is just where we want that. Oh, I'm sorry, my face is so massive. Can't see over your shoulder. Thanks, Paul. Sorry, I wasn't looking at the chat. I need to do like 6 things at once. I've got to tell you, it's a miracle it's going this well. Seriously. Okay, I'm about the right size now. So, so that's a 3rd pin. So now I've got 3 pins. And the beauty of this is, if I want to get fancy, I can actually just, because I've made it around a square, I can actually select these 3 pins. And again, I can go right click, move and copy, and I can make another copy. So I've got 6 pins now. Each one of those blue things is actually 2 pins together, but I can actually rotate those around the origin. So I can select this pivot and I can make it the origin. And then what I can do is spin it around. So there we go. So I've got 6 pins now and they're all in the right place. So I click OK. Perfect. Now if I put top of the sieve back, essentially this is the whole thing done now. What I might do is put 1 pin going vertically between the 2 patterns. I don't know whether I think I should probably do that just for completeness. But what I'll do now is just show you how to make, obviously I think most of you guys know how to do it, but in case someone's watching that doesn't know how to do it, what you can do is select the part you want to make the hole in. Basically lots of these programs work by subtraction and addition of solids, and what you can do is, because I've made this pin, this is the shape I want the hole to be, not the pin, I can select this whole object here and I can do this. I can combine it with, and I can combine it with these things here, these, and what if you look here, I've got it set to cut, and it's actually going to cut those pins out of this blue body. Now I'm selecting keep tools because I actually want to use these tools. I want to keep them. If you had that unselected, it would use up these pins in this operation, but I want to hang on to them. So I'm going to keep the tools, I'm going to click OK. Now what you'll see is, if I just delete that, now we've got a hole. And not only that, it's actually chamfered at the back. Okay? And same for this one. And the same at the other end too. So, I'm going to delete that. Not delete it, I'm just going to hide it. And I hide that. Now I'm going to do the same operation for this bottom of sieve. So I select bottom of sieve, combine it, select my tool bodies. That's already set to cut. It was what it was on before. Select the pins. I'm keeping the tools. Okay. Now I can hide those pins. And voila! Super duper. Basically, if I just print 4 of those green corners and 4 of these red corners, that would be the entire sieve pattern. I think I'm going to have to account for the, like Tobo mentioned before, the width of the mesh, but I possibly, how long have I been streaming for? Oh my goodness, for 39 minutes. I probably won't do that now. If I put the mesh in, you can see here the idea. Essentially, I'm not really sure where I'm going to put it yet. I think I probably will put it in the green, which is the drag. But the mesh, so it's going to be like this. In fact, let's do this properly. Top of sieve, I want to hide the bottom. Top of sieve, top of sieve, top of sieve. Okay. And we want the drag. So, essentially, I've rammed it full of sand. And I think where this mesh is, I need to have, well, it's obviously when I'm ramming it up, it'll be this way up. But where this mesh is, I think I'm going to, the red side will be easier to draw out of the mold. Yeah, you're probably right. I'm only putting it on this side because of the kind of the small size of the red. My goodness, my brain. But basically, well, it doesn't matter which way. What I'll do is I'll print, like Tobo said, and this was my original plan, to print a spacer that would take up the space of the grid, the mesh. So that will enable, hopefully that will enable, assuming I've cut the grid roughly carefully to the right shape, that will stop the drag and the cope separating and then aluminium pouring out the sides, or places where it shouldn't do, if you see what I mean. So that's the kind of plan, and I'm hoping at this kind of boundary where they join, I'm hoping that's what's going to hold the mesh in the actual sieve. But like I said before, the mesh might get too hot, it might warp. It might warp while it's molten, and then YouTube's telling me the stream has gone bad. It's got 4 bars still. I'm just going to plow on. But it might sort of warp, it might expand, say, once the mesh is hot, but then it might kind of freeze whilst it's bowed and hot. I don't know. It could be a total disaster, but it's kind of a nice exercise in I wonder what will happen. Also, it'd be nice to have a little sand sieve that's got nice round corners. I've got a feeling when you look at the sieve finished, there's going to be quite a bit of aluminium sort of overspill in these sort of first rows of the grill, of the kind of grid. I don't know. That's probably going to be a thing. But it's a bit of a fun experiment. So I'm going to get rid of the drag. I'm going to bring back the bottom of the sieve. In fact, I'm going to get rid of all the extraneous stuff that we don't need. So we're back to this. Now I'm going to quickly, let's take one of these pins. I'm actually going to put a pin here between the two. Let's put that, let's copy this, move and copy. Create a copy. So I'm going to move it that way by an arbitrary amount. Let's say actually, let's move it a fair bit. 16. What happened there? Oh, I did 600. Of course I did. 60. Right. And let me just... Right, I want to rotate this now. What's half of 27? 13.5. So now I need to reduce this by height to 13.5. Because that's the total length of the pin. Hopefully the stream is working. I'm still seeing problems on my little widget here. Can you guys still see? And so that's this pin here. And, oh, that doesn't seem right. 13.5. That's not enough, is it? Oh, it's because it's a certain height above here. Working fine at my end. Brill. Thank you, Tobo. Thank you, Paul. So what's the height of that? I think it might be 5. I think I might just need to add 5. 13.5, 3, 4, 5, 6, 7, 8. So it's 18.5. Let's try that. No, let's do the other way. Maybe it's 4. Let's do 17.5. That looks about right. Okay. So that pin goes there. And like before, I'm just going to essentially copy this pin. Oh, I've called it PIM. God, my eyes are terrible. Pin, vertical pin. So I'm going to copy that. I'm actually going to put another one in. Do I need... Let me think. Well, let's try it. I'm not sure if it'll work the same. Select pivot. This might not work out. It's difficult to me to think whilst doing all this technical stuff. Gotta go. See you, Perry. Nice to see you, mate. Now, at what angle? See, this is the trouble. At what angle is it in the middle? Yeah. Not ideal. Well, I can do... Yeah. So let's forget that. What I'm going to do is just going to copy one and move it by move a copy. So I'm going to, let's look at it this end on and just go like this. Oh look, it's 50. That's the beauty of keeping everything nice even numbers. So it's 50 that way, and it doesn't really matter. Oh my goodness, I'm a numpty. I didn't copy it. Move copy. I didn't select that copy. So let's go. Got a feeling. Let's call it 90. It doesn't really matter. And then we're going to move it this way. I think we said 50. Minus 50. Cool. All right. So like before, essentially all I'm going to do is subtract these pins from the green part. So I'm going to select the green part, which is top of sieve, combine, select the tool bodies which are going to be subtracted, and that's the pins. I'm going to keep the tools because I need them to do the same on the red bottom part too. So that's done. If I just hide top of sieve and I now do it, now this is the this is the trouble. Okay, see, unforeseen circumstance. So obviously these pins are too long. So what I can do is select that pin and that pin, move. Now let's move them up so that they're not sticking out the bottom. If I click there, so that means the bottom of them is right on the surface there. So I want them to actually go up. Let's say I want at least, yeah, let's just say 6.5. Okay, so now they're mainly in the top half, but it means that I need to subtract them again because otherwise the holes won't be big enough. So let's hide the bottom of the sieve, select the top part, combine. Let's remove these now large, higher up holes. Okay. Hide the top, reveal the bottom, and combine that with tool bodies, just subtract again. Now if I remove all these pins, hopefully there are holes all over this thing that line up with holes there. So basically with those pins put in, this would be held together decently, I think. Because I don't actually like to glue my patterns together, because I don't know why. I like to be able to change my mind and make a new piece. So now I'm using pins rather than glue. I could make super easy. I'm not going to bother you guys with it now, but I could go like this. I could go, ignoring the pinhole, I could go like this and make an extension piece that was 50, not 5,000, 50, like that, new body, and I could print that, and then I could have the four corners and insert the two sides, a bit like the modular flask. It could be modular and you could change the shape of things. I don't know. It's nice to be flexible rather than once you've glued something, you're kind of stuck with it. So right, I'm going to get rid of that. That's pretty much it, except for, I think, making it a little bit more pleasing to touch at the moment, and also remove from the mold. This edge here is quite sharp. That's actually, what's the width of that? 3.7 millimeters, it says it down here. What I might do in the next 10, I think if I can get this stream done in 10 minutes, that'll be awesome. So I'm going to just round over all the sharp edges and send one of these prints off for printing. The mesh what I will actually do is, I won't show you. In fact, I'm going to quickly show you now. I'm going to move. I'm going to make a copy. In fact, I'm going to move copy. I'm just going to copy and paste. Now, this is copy of mesh. Right. Essentially, I'm going to 3D print the mesh so that it actually takes up space for when I'm ramming the sand. I think that's the best. The other way I could do it is separate these two parts separately and make one of the parts have a kind of a lip on it. But the problem with that would be it wouldn't print very well. It's really nice to have a print surface that is super flat, and a triangle is lovely to print with. So I think what we'll do is, just to show you here, this mesh, I'm going to split it, and I'm going to split it. This is literally a quick example, and I'm going to split this part here. Oops. Beep, beep, beep. Body to split that one. Splitting tool, that one. Okay, so let's get rid of that and that. And then you see where it impinges here. I'm actually going to remove that. So I'm going to select this mesh. I'm going to make it a different color now because this isn't a mesh anymore. This is a pattern for the mesh. Ralph, this is Fusion 360 is really good. Oh my God, you're going to get a 3D printer? Mate, it'll change your life. It's literally changed my life. Nikki, my wife, would probably say it's changed hers because of the lack of sleep. Our bedroom is directly above my office, and sometimes we just go to bed listening to 3D printing. Okay, so what was I doing? Yes, I was going to, using subtraction, so I'm going to make a pattern for this mesh. So this is no longer the actual mesh, this is the pattern for the mesh. So I'm going to change its appearance just for ease. Just keep it nice and simple for us. Let's make it, what's a nice easy color? Yellow. Daniel, I don't know about Fusion 360. Sorry, I don't know about FreeCAD. I know it's good and it's free, which is great. I know there's been a little bit of controversy with Fusion 360 changing their plan. It is still free. You can still access all this stuff for free. You just have limitations on the number of active documents you can do at one time. But for kind of simple stuff like this, the free version is more than enough. So this pattern here for the mesh, I'm just showing you this. I probably won't do this. I don't know. I might have to finesse this slightly. I might make the pattern for the mesh slightly thinner than it needs to be, because I think the sand will actually go between the mesh part holes nicely. But what I'm going to do is I'm going to take the mesh and I'm going to combine and subtract again, and I'm going to use the actual top of the sieve, and you can see here it's now cutting the pattern of the mesh at the perfect angle, which in our case is 3 degrees, because that's the draft we gave it when doing the top of the sieve. I'm going to keep the tool because it's part of the sieve and I need it. Done. Now if I get rid of the top of the sieve, there you go. So I could 3D print this. Now I wonder if I need to... Now because this is no longer... Is it symmetrical? Yes, it is, because it is. So I don't need to make a kind of a mirrored version. If this was rectangular, I would have to make it a kind of a mirrored version, but I don't need to. So really, we're almost there. 4 minutes to go. So all I'm going to do now is tidy this up. I'm actually going to save it. Let's save it. Livestream B1. Now, filleting. I love filleting. It's basically, it's essentially taking a sharp corner and rounding it over. It's nice for the touch. It's also nice for removing parts from a pattern. Sorry, I'm looking over here at the chat while I'm talking to you guys. I should be looking at the camera. I'm such a noob. So what you do is you select fillet, and literally select any edge that you want to make rounded. Fusion is very, very good this way. I'm actually going to select more than one edge, and I'm going to say 1 millimeter. Now, if I zoom in, it's only a little bit, look. It doesn't need to be huge. If I make it 2 millimeters, I don't know, to me it's actually reduced the height of it slightly. I could go 1.5. Yeah, that's quite nice. Maybe I'll go with 1.5, and that'll be a nice rounded over top. So I click OK. Now that's permanent. Now notice how I didn't do these edges. Because these edges shouldn't be rounded over. These are actually going to be butting up to the other corners, so they need to be sharp and flat. But equally, I'm going to do this. Oh my goodness. I moved my mouse thing slightly. So fillet those. Now let's do 2 on that. See, 2 on that is plenty, is perfect. Might even go 3. Yeah, 3. Why not? So that's essentially the pattern for the sieve. Now I don't know whether yet to, like Ralph mentioned earlier, no, Tobo mentioned earlier, whether to put this mesh pattern in the top. See, I could put it here, or if it was a different shape, I could put it here. So I could put it in the drag or the cope. It may be worth thinking about that more, but it's not something I can think about whilst also doing live stream and kind of feeling the dead air while I just sit here silently thinking. But I think that's essentially it. Now all you do with Fusion 360, I don't know about other software, is you select the things you want to print, and it's super easy. You just go right click, save as STL, and now this is off screen, but I'm just going to make a folder called Livestream. Just one sec while my ancient computer drives warm up. Honestly, I've got like 14 terabyte. I've got a ridiculous amount of drives because of all my footage. I think I'm nearly at I don't know, 12 terabytes or something. All right. So you literally save it, top of sieve, super simple. And let's save. So obviously the pins aren't needed. They're literally going to be physical, these things here. So they are going to be slotted inside those holes. So they don't need to be printed. I'm going to also need to print the bottom of the sieve. Select Save As. All right, bottom of sieve. And why not? Let's do the mesh too. Save as STL, mesh. Perfect. Now, because I have a make the core print. Tobo says, looking great, thank you, mate. Make the core print a loose piece, then it won't make it harder to draw the pattern. So it can go on either side with. Yes, I will probably do that. But we've gone over by a minute, so I'm not going to do that now. But essentially, because I've got a Prusa slicer, because I've got a Prusa Mark III S, which is the latest version of the. I've actually upgraded it from the previous version, but it's a Prusa 3D printer, and here is literally a model of the print bed. Actually, here is something that I wanted to put in to the model. Now this is one of my nut traps that I really love. Let me go and get it. I actually printed it just now. One sec. Right, let's make this nice and big. Now, can you see I've just printed this? This is the thing in the background here. I've just printed it. It's probably going to be out of focus, but it's an example of a nut trap. Now, I used these on the modular flasks, and what you can do is you can push, that's a perfect shape to 3D print upside down, and you can push I think it might be M3 nut in there. And let me do that. So you can see I've pushed an M3 nut in there. And if I push hard, I can push it all the way in. And this shape is particularly useful because you can get these little bolts that have got a kind of 45-degree head on them. And what you can do is, why is this useful? Well, in a part like that sieve, where it's quite deep in the sand, if you put these shapes, like I would probably put, I was probably going to put a nut trap, I don't know, say here on each corner. And what you can do is, when you're ready to remove the pattern, unscrew that little flat nut and then put in a regular sized nut. He says. Oh, incidentally, once you get a 3D printer, you can 3D print, like I've designed this little set of trays that hold all my nuts and bolts. Oh, here we go. So you can put a regular, still too small. I need the next size up. Oh, there we go. I'm beginning it. So you can put that in there and then use it as a handle to pull your pattern out of the sand, because it's really difficult to pull long, thin patterns out of sand, particularly this kind of shape. You can imagine the friction on the sides here is quite high. So I will probably, before I print these proper, but you don't need to see this because I think the stream is going on too long, I will just put this shape and I will subtract this shape into this green body here, so that when it comes to the actual casting, the actual making of the mold, I'll be able to remove it easily, I hope. I may even put it on the other side too. But anyway, so let me just quickly show you how you would print these things. So this is my slicing program. I'm going to delete that because I've already printed it. I will add, and I've literally just select all the bits that we saved from earlier. Yeah, you can totally use the bolt for wrapping the pattern. Thank you, Ralph. I also agree with you. Brilliant. I'm very proud of that. I'm sure it's not even a real invention, but I just kind of thought, when I was doing the modular flasks, because they're so fiddly, and I don't know, it just takes so long to do those molds, that I'm probably overly pleased with that ridiculously bad invention. Right, so all I do is import those three things, and there we go, look. You've got the mesh pattern, so you've got the top of the flask. Oh, sorry, I've got flasks on the brain now. I've got the top of the sieve, I've got the bottom of the sieve, and I've got the pattern. Now I would need 4 sets of this. Now you'll notice this part here. Oh, now this is weird. This mouse doesn't behave quite the same way in this slicer. Okay, so this part is the correct way up for printing. It's got its flat surface there, and it'll print up, and then it's got the rounded surface on the top. Now I could totally print this part this way up, but it would make much more sense just to flip it over and have the flat surface on the print bed, and have the kind of curved surface. I don't know. It would make this curve more accurate to have it on the top. So I'm going to do that. And on Prusa Slicer, it's super easy. You just go like place on face. He says it's frozen. It's frozen. Okay. You click place on face, and it highlights all the flat parts of the object. And this is the flat surface I want to use. There we go. So now you can see, if I move this out of the way, you see it's now being printed the right way up. Now for space saving, I'm also going to rotate it. Super easy on Prusa Slicer. There we go. Now this piece I think is fine. There's like a little overhang of 3 degrees. We don't care about that. That's fine. So that can be printed that way up too. So all I would do to print these as they are. Now actually I could probably get rid of those, and I wonder if I could print copy, and I wonder if I could go 1, 2, 3. I wonder if I could print all 4 at once. Do you see what I mean? I could like wedge them in. Probably not. Probably not. But you could certainly do half of it, if you see what I mean. But for this example, this is the beauty of cutting it into quarters. You can actually fit lots more on your printer. So let's just get rid of all of them bar one of each, and arrange it just sort of nicely. I won't do the mesh pattern for now. And all you do is select your quality. I'm doing 0.2, bog standard. PLA is the material I'm using. That's the easiest and most cheap material there is. Infill at 15%. That's perfectly standard. Now I like to use an infill gyroid. It's kind of slow but nice and strong. And that's essentially it. You click slice. Wait 10 seconds. Done. And then the program has essentially got all the 3D instructions for your printer, your toothpaste tube of plastic, just to go. So at first it'll do like a flat plane like that, and then it'll go up, and then it'll do the wiggly. Oh, my face is too big again. Face too big. Essentially that's it. And you'll notice that where it comes to the holes, it'll do those as well. You see it'll go over and then overhang and then fill over the gaps. And that's it. So what I'll do is I'll print these. I will probably put in the nut traps just to make removing the things easy. And then we'll cast it on the next part. I'm very sorry I've not been a good YouTuber. I'm so chuffed you guys came to listen. Thank you so much for coming and watching. It's been brilliant. I can't believe I was imagining like maybe one person. I don't even know how many people we've had. Concurrent viewers, 10. That's amazing. So yes, goodbye. You guys are totally awesome. If you like this kind of thing, I might do this again. Maybe, I don't know. But if you want to watch the casting, click subscribe, hit that goddamn stupid bell, and then you'll get notified when I do the next part. I'm actually going to do the casting of this as a test for my furnace. I literally haven't used my furnace in maybe 7 months, and it's getting very rusty. So I might need to do some patchwork on that. But when it's working, and this casting has worked to prove it works, I'm doing a collab with someone that might have been in the chat. And that's very exciting. And yeah, essentially, hopefully I'll be getting back to casting again. But this will be out of aluminium because it's nice and light, and it's quite a big old object, so I don't want it to be really expensive and bronze. That's it. Goodbye, guys and girls. Let me just quickly... Top of sieve, bottom of sieve. There we go. Yeah, that's it. Bye. Thanks very much for coming. It's been brilliant. Cheers, guys. I don't really know what I'm doing now. Cheerio, Kevin. Thanks, Daniel. I'll do a little shout out. Paul, Tobo, Kevin, SW Dweeb, Perry, Ralph. Take care, guys. You guys are awesome. Right, I'm really going to press it. I think I just pressed this end stream button. Bye.